As we saw last time, b squared minus 4ac is a critical part of the quadratic formula because it allows us to determine not just what the overall solution is, but it can also tell us what type of solutions we have. And there's three basic possibilities. It's either going to be positive, sorry about that, it's going to be either be positive, 0, or negative. If it's greater than 0, if this thing turns out to be greater than 0, then there's going to be two distinct real solutions. If it's equal to 0, there's going to be a double root, which we saw in one of the examples previously, which provides us with a single distinct real solution. And finally, if it's negative, we have a square root of a negative number, so there's not going to be any real solutions. All of the solutions are going to be complex. So let's take a look at this. Now, we just solved each of these problems. So I'm going to dive back into the problems here. We did this 6x squared equals x plus 15. And if you think back, when we put it into standard form, it turned out to be that b squared minus 4ac turned out to be 361. So as soon as we solve that, oops, sorry about that. As soon as we know that because it's 361, this result is greater than 0. And if it's greater than 0, we're going to have two distinct real solutions. So we get two real solutions. In the second problem, you'll recall, if you look back, that the b squared minus 4ac turned out to be negative 144. A negative 144 means that b squared minus 4ac was less than 0, and so there were 0 real solutions. In fact, we saw that both of the solutions were complex. In example 3, we got a 0 for b squared minus 4ac, and so based on this, if b squared minus 4ac is equal to 0, we get a single distinct real solution. So one real solution. And remember, let me go back to that. The fully worked out solution gave us 1/3 as our single solution. It was 6 plus or minus the square root of 0, if you recall. So based on our answer for the discriminant, we can determine the nature of the solutions, how many real solutions we get. And finally, let's take a look at this last one. I think we got b squared minus 4ac was equal to 88. Now, I want to just kind of distinguish 1 and 4. Both of them are positive discriminants, which give us two real solutions. But if we want to drill down a little bit further, we can even make a further determination that because the square root of 361 is 361 is a perfect square, the perfect square simplifies out exactly and gives us two rational solutions. Whereas square root of 88 is not a perfect square. And so the square root of 88 doesn't simplify down to a nice solution, which leaves us in an irrational state. Now, we didn't really talk a lot about rational and irrational numbers, but suffice it to say that a square root that doesn't simplify out to a whole number or a real number is, out to a nice, easy number is irrational. So I'm going to leave it at that. That's a very poor explanation, but it's the best I'm going to do right now. And we can always go back and look at the difference between rational and irrational numbers a little bit more in detail later on. Okay, so how many distinct real solutions does this equation have? Well, let's use the discriminant to figure it out. This is really x squared plus 0x plus 15 equals 0. So b squared minus 4ac is equal to 0 squared minus 4 times 1 times 15. And we get 0 minus 60, which is negative 60. Negative 60 is negative. And so since it's negative, we get a negative discriminant, which means no real solutions. Both of our solutions are going to be complex. And I guess that's it. So for discriminant, it's real simple. Look at the b squared minus 4ac. If it's positive, two distinct solutions, both real. If it's 0, there's one distinct real solution. And if it's less than 0, no real solutions. Both of the solutions are going to be complex.